So thank you a lot one more time for joining. I hope my talk will be interesting for you. So as Ira said, I'm Mariya or Masha. Now I'm working as a lead analyst at Wise. I'm like data or product analyst. So the main goal of my team is to help product team to make right decisions based on data. Overall, I have more than 10 years of experience in data and product analytics. As Ira said, I've been working at exact team where ClickHouse was born for more than 6 years, and I've made quite a lot of presentation about ClickHouse. And later on, I will tell you why. As you may see, I'm an analyst. I'm not a software developer, which means that my perspective is more from user point of view, but I've been helping a lot my previous team to administrate ClickHouse, and I know quite a lot about the features. That's why I would like to share with you why you should think about using it. So first of all, just to understand the audience, please write +1 or something to the chat if you are working with big data. Oh, yeah, I see. Cool. Oh, even with ClickHouse, it's pretty cool. Because my next question will be have you ever heard about ClickHouse? I've seen that someone heard, so it's pretty cool. And first of all, I would like to share with you my personal story, why I really like ClickHouse. When I started working as a data analyst 10 years ago, I was a junior data analyst, and the only tool we have in a company was MapReduce. As Ira said, I've been working at Yandex, and Yandex, it's actually not only Russian Google, it's actually Russian Google, Uber, Amazon at the same time. So I used to work with tens and hundreds of terabytes of data, and MapReduce was the only option. And my common day-to-day routine was come to work, start some kind of script to calculate something, let it be conversion rates for different regions. Then if you ever try to write a MapReduce code, you know that there's map stage and reduce stage. And it was the time when there is nothing like Hive, what is SQL interface over MapReduce. So it was really about running low-level code. And in many cases, in several hours, I might recognize that the script was failed on reduce stage, and then I need to restart script. And again, it may take hours, and maybe only by the end of the day, I can get some results based on data. And, it's very, very long process. And as an analyst, we usually have to look at different hypotheses, calculate a lot of different stuff. That's how ClickHouse changed the way I work, because with ClickHouse, it's possible to calculate similar stuff just in seconds or minutes and not in hours, which is game changer, because you can prove more hypotheses, you can get more insights, you can get them quicker, and it's pretty cool. And today I will share with you why and how it works. So the plan for today, first of all, let's discuss what is ClickHouse, what are the main features. And I think the most interesting part is when you should and should not use it. So let's start with what is ClickHouse. And, I decided to ask ChatGPT because it's popular now. And I was really surprised that the GPT knows quite a lot about it. My partner even joked that there is no need for me to talk about it because GPT knows everything. But still, I believe my experience may be more valuable after so many years of using ClickHouse. So what it is exactly, ClickHouse is an open source, comma-oriented distributed OLAP, which is online analytical process and database management system. A bit of a history. I think the first question may be what does this name means? And actually, it's a combination of two words. It's clickstream and data warehouse. It's pretty often abbreviated to just CH for shortness. It was initially developed in Yandex Metrica. It's an analytical system, something similar to Google Analytics. now it's the fourth largest web traffic analysis tool in the world. Yandex Metrica just like helps to understand customers' behavior on site. For example, you have your own site and you would like to understand what is the customer's behavior on site, like what pages they view, what I don't know, goods they purchase, and so on. So it's like quite a lot of data about every single aspect of customer behavior. So like, what was the browser of customer? What was the duration on each page? What was the URL, and so on? So actually, like Yandex Metrica captures data around like billions events per day. The current state of cluster, it was 2 years ago, the last public data I know. It's about 100 petabytes of data, and it's around 1K servers. So far, I believe it's not the biggest ClickHouse cost in the world, but it used to be. And like as an analytical tool, we need to generate reports to our customers on the fly, because like no customer will be, I don't know, waiting for an hour to see results and like what was the customer behavior. So like why in the end ClickHouse was developed at Yandex? Before ClickHouse, Yandex Metrica used pre-aggregated data. So it was storing data in the view when we have everything pre-calculated. So for example, like here, we know that for site Women Who Code, on the 8th of March from Google Chrome, there were 10K users, and they made like 15K sessions. What's the problem of this approach? First of all, that we can serve only some defined list of available reports and data for analysis. We can build like custom report, because like with this data structure, it's pretty difficult for us, for example, to calculate what will be the number of users for a month, because like we can adopt sessions, but we can't adopt users, because like same customers can went to the site several times on different dates. So it's usually some kind of defined list of reports we can add up, for example, to add up another dimension, for example, browser version, we need to pre-calculate it again. The other problem is then we aggregate over a large number of dimensions, and some of them may be like with a high cardinality, like URL, which means that like there are a lot of different unique like values for URL. So which means that volume of data may even increase after this pre-aggregation. So when you're grouping by URL, you will have almost the same number of rows as in raw data. The other problem is that we need to show data in different combinations. So for example, by browser version, by operational system and browser, by operational system, browser and date, and so on. So it's like a combinatorial explosion. So there will be like enormous amount in data. And as for me, it's like the saddest point that all these calculations are really in vain, because like users usually view only a little portion of these pre-aggregated reports. So some users are interested in browser view, the other ones are only looking at metrics by date. So like we are doing lots of calculation and like no one sees this. That's why team decided to switch to raw data view. Which it means that like each row in our data is exactly like one session. So instead of like holding or keeping information like how much users and session visited from each browser, we just store information for each session as a separate row. So which means that like now we can calculate anything. We have all the raw data, we can do all aggregations on the fly. It's extremely flexible, but it's like it also have its limitations. With pre-aggregation, most of work was done, most of work was done offline beforehand. So when we need to show report, we can just like select data that we need and that's it. But like with raw data, we need to process like petabytes of data we have on the fly, and it requires a suitable tool for it. And like the best well-known solution for it, it's called Mariya databases. And at this time, there were several such systems in the market. It's like Vertica, Amazon Redshift, Exasol, InfiniDB, and so on. But unfortunately, all existing solutions were not the best fit for Yandex Metrica, mostly because of two reasons. First of all, commercial versions like Vertica will cost us like enormous amount of money, like because we are storing like petabytes of data. And unfortunately, open source solutions were not supported at this time. That's why team decided just like to build their own version. And they started doing it in 2009. And the first version was internally launched in 2012. But like the most interesting part was that when in 2016, ClickHouse was open sourced under Apache 2 license, which means that like it can be used even for like commercial development. And more than that, in 2021, ClickHouse was incorporated in Delaware. So now it's not part of Yandex. And it's like unicorn startup with $2 billion valuation. So it's like pretty cool that it's like now independent company in US. Recently, they also started distributing ClickHouse not only as open source software, but also as cloud offering. And quite a lot of company all over the world is using ClickHouse now. It can be like Uber, Spotify, eBay, Cloudflare, and so on. Actually, when I was looking for a job, I was trying to filter a list of companies, looking at companies who are using ClickHouse officially, which was pretty cool. So let's speak about what is unique in ClickHouse. It's a funny part of documentation in ClickHouse. There is a special page in documentation that explains the motto or slogan of ClickHouse. As you've seen on my very, very first photo, it's me presenting something about ClickHouse, and it's like official ClickHouse t-shirts. Since it's like initially it was developed in Russia, the slogan was in Russian, but then on one international event, they started to give away this initial Russian t-shirts, and people keep asking like, what does it mean? And it's like a motto, or I would say a mission of ClickHouse. It can be translated in two ways. Like the most straightforward one, it's like ClickHouse doesn't press the brake pedal, but like in the meaningful way, it's more about if your large system lags and is slow, it's definitely not because of ClickHouse. And it actually shows us the speed is number one feature and advantage of ClickHouse. Because it was developed as a part of an analytical system. And the main challenge for us was to calculate reports instantly for our customers. So ClickHouse was specifically developed for speed. Like it really allows us to calculate reports with petabytes of data in seconds. According to ClickHouse benchmark, it's hundreds or even thousands times faster than traditional databases, and it can process tons of gigabytes of data per server per second. Actually, it's a bit cheating. We all understand that comparing ClickHouse speed to, I don't know, like MySQL or Mongo, it's a bit weird way because like these databases were not intended just like to do analytics. But if we look at ClickHouse official benchmark, it's even a bit faster than Redshift, what is like also an analytical database. But you know, if we are looking at official benchmarks, they usually show us a little bit skewed picture or biased. So I tried to find a more independent one. And it's a benchmark made on, as far as I remember, it's New York taxi rides data. And like we can see the ClickHouse here is on the second place after KDB plus Q database. It's actually the first time I've heard of it. And like we can see that ClickHouse is 4 times slower. So you may wonder why on earth are we talking about ClickHouse and not this KDB plus? I tried to Google it, and KDB plus is column-based relation and time series database with in-memory abilities. And taxi rides data sets is around 500 gigabyte in size. So it's relatively small compared to petabytes. So definitely, if you just need to calculate, like to process around hundreds of gigabytes of data, it's okay to use in-memory database. You don't need to use ClickHouse. But like ClickHouse is a good solution, and it was using it when you're working like really with big data. So I would say that maybe here KDB Plus is a bit overestimated if we're talking about big data, but like still can be a good option for your task. Other features of ClickHouse that I really like, it's like rich SQL dialect. It's more for me as an analyst, as a user. I really appreciate approximate calculation. It's like in ClickHouse, there are a set of features that allow you to have this lever for trade-off between accuracy and speed. So in many cases, like especially for analytics, for example, when we would like to calculate the audience of a big site like Google or YouTube, there is no like no much sense to calculate it exact number up to one customer that visited your site. It's okay to know that it's like 1 billion and that's it. So this approximate calculations is pretty useful for these tasks, but like you definitely need to keep in mind that it's not always suitable for your task. So for example, when we would like to calculate how much money we owe to someone, we definitely need to use exact calculations. The other cool stuff is about array supports and powerful functions like above arrays. It's something similar to MapReduce filter in functional languages. It also supports local and distributed join. ClickHouse is hardware efficient, so it can work efficiently even with HDD, not only SSD. It minimizes data transfers across servers, optimizes disk drive access, so it allows you to work either at your laptop, as I pretty often use it because I like the dialect, or on a cluster with thousands of servers. Also, it's like fault tolerant, it supports multi-master replication, and it have equal nodes, which means that there is no single point of failure. Actually, it's pretty easy to try. If you would like to try it on your laptop, it's just like 3 lines of code. First of all, to install it, then to run server and to run client, and then you will see just a client terminal running on your laptop. And as I've said earlier, they also now allow a cloud version of it. So if you're interested, you also could try it in a cloud. But like the most interesting question, I would say, is like when to use ClickHouse. As I said, ClickHouse is an OLAP database, which means online analytical processing. And the main characteristics of this use case is working with white tables with many columns, the normalized view. It's that in your columns, values are pretty small. So it's like numbers or limited strings. So like we're not storing big text in the columns for ClickHouse because it won't work efficiently. In many cases, we were pre-processing data to parse needed information from, I don't know, like JSON files and so on. During query processing, usually large number of rows is used, but like small number of columns. Result of the query is relatively small and it fit in a server, in one server memory. So actually like the use cases for OLAP is either filtering. For example, I would like to see all the actions from one particular customer and get out of like billions rows, just like 10 to 100 of them, or calculate an aggregation. So how many customers visited my site on each day. Inserts usually happen in batches, not row by row. Transactions are not needed. Updates are rare. Actually, ClickHouse didn't support updates like for ages. As far as I remember, updates and deletes were introduced like 2 or 3 years ago. We will talk a bit about it later on also. So just like to show you the difference, what is the difference between normalized view? For example, if we have a session and for each session there is a specific user in normalized view, like we used to do in many like classical databases, we would either create a separate table for user and specify each user parameter, like the country or age or first date when user was created in a separate table. And when we need to calculate something, we would rather join these 2 tables by user ID, just not to repeat in every single session all the user parameters. And surprisingly, in ClickHouse, we're using it exactly in opposite way. So which means that like we are really repeat in every single session, all the same user parameters we have. And why it works. It's a cool visualization. I suppose it's pretty descriptive from ClickHouse side, and it shows just like exactly why it works. In column-oriented databases, we store the data like by columns, and when we are calculating something, we access data only regarding the specific columns we need. So for example, here it shows like that we need to calculate something by time, location, and mobile phone. And we only access from these three columns. We are not reading data for each row. We are just like accessing needed columns, and that's why we can store so many columns. Because, like for example, in Yandex Metrica, as far as I remember, for one table we have around 200 columns. For the other one, it was around 500 columns. But in most of the queries we were using, I know, 10 to 20 of them. So the other columns, we are not accessing this data, it just stored on the disk. So ClickHouse was definitely developed especially for this OLAP scenarios. So like it works fast and efficient for this scenario specifically. I like this idea that the no system can work equally efficient under high load in significantly different scenarios. So like that's why it was specifically developed for this one. Some examples of OLAP use cases, you may try the easiest way, and the common one is just to try use ClickHouse with your log. It can be either access log or application log. Also, it can be like analytical system, any type of monitoring systems or telemetry, e-commerce data from your site, and so on. So anything about like events with lots of characteristics. The interesting question is like, why ClickHouse is so fast? First of all, it's because it's column-oriented storage. I've described recently. Also, column-oriented storage allows us to compress data much more efficiently. So, for example, we have a separate column for browser, and as I said, we have like billions of rows of data, but actually in the world there are up to, I don't know, like 30 or 50 browsers. So it's a lot of repetitions in this like file that where we store browser data. That's why we can like compress it pretty effectively. And on disk, it will just require much less space and size. Also, all calculations are vectorized, which means that like we're not calculating data for each row. It's somehow optimized to do it as a vectors. It has index access. It has scalability on one node and the whole cluster, and allows approximate calculations that I've described earlier. Also, if you're interested about like building a fast system, I would really recommend you to watch the video of Alexey Milovidov. He's one of co-founder and now CTO of ClickHouse. As far as I remember, initially he was almost like the only author of ClickHouse. So I suppose like initially he wrote around 95% of code for this database, which is like pretty cool. Also, I like it's the one I found in the documentation. I really like the wisdom from ClickHouse how to build a high performance software, because like it's one of motto and mission of ClickHouse. When they are implementing every single feature, they still try to not to damage the speed of the database, and speed is the only one focus. So I really like how they are focused on making ClickHouse really fast, because it's like unique feature of ClickHouse, and it's I believe it's the #1 argument for using it in production or for your work. So ClickHouse, just like to sum up, ClickHouse has been developed specifically for online analytical processing use case, and like the best use case for it. If you would like to try it, please start using it for this one. And the other interesting topic is like when not to use ClickHouse. First of all, it's better not to use ClickHouse with online transactional processing tasks. So when you need transactions, as far as I remember, ClickHouse still doesn't support transactions at all. As far as I remember, transactions has been in roadmap for ages, but I've never seen any strict deadlines for it. Also, ClickHouse won't work as a key-value storage. It won't work efficiently in case when you have lots of denormalized tables, so joins may be not so effective. Usually it's advised just like to pre-process data for ClickHouse, to do joins maybe somewhere else when you're writing down rows to ClickHouse, and in ClickHouse just to store denormalized data. For example, like for Yandex Metrica, we had just like 2 tables, and that's it. And they were very, very rare joins. The other limitation can be that ClickHouse won't be very effective to handle real-time mutable data. Update and delete operations were introduced pretty late. It was like 2 or 3 years ago, and it's not native. It's some more about asynchronous mutations. And then like you may ask how on earth analytical system can track websites activities without any updates and deletes at all. Because like, for example, when we are working like at Yandex Metrica, we had 2 types of entities. First of all, it's hits or events. And for them, it's pretty easy. It's like any type of event, for example, like you opened a site or some mouse clicks, whatever. So they are only added, no updates or deletes. So in case customer open site, like event has happened, there is no updates to it. But like with visits or sessions, they usually can be updated multiple times. So during one session, customer may do different actions, duration will be changing, and so on. And while for hits, it was okay to use only inserts. For session, there is functionalities that allow to do asynchronous updates with only inserts. It's a special table engine called collapse and merge tree. Actually, there is a family of such table engines that allow you to do some kind of asynchronous merges. So it's like collapse and versioning. Also, some of these table engines allow us replication. And this idea is called incremental log. I really like it. That's why I would like to share it with you. So, for example, we have a customer, one customer session, customer visited our site. In the beginning, it's like 1-page views. Like customer viewed 1 page, we know the browser, duration is 0 because like customer just opens the page, like not much time left. And now customer visited another page as a part of the same session, and like we need to update number of page views to 2. What can we do for it? And the cool stuff is that we can just add 2 more rows. It will be inserts. The first one will have all the same column values, but it will have a sign -1. And the other new one will have updated values, but it will have sign again 1. And like page views will be updated, and like duration will be updated, but like date, start date, browser will still stay the same. And then asynchronously, ClickHouse will just collapse the rows with the same values, but different signs. And like in the end, there will be only 1 row for this case. But in the meantime, we still need to do some kind of calculation, and it's pretty easy. Just like every time when we need to calculate sum, average, or whatever, we need to use sign mark. So like for sessions, it will be just sum of signs. And for page views, it will be sum of multiplication of sign to page views. So like these 2 rows with different sides, when we will be calculating, it will eliminate itself. So it still will be 2 page views, even until collapsion has happened. Yeah, as I said earlier, ClickHouse is open source. So if you are interested and if you know C++, you can contribute to it. There will be a guide, link to guide if you're interested. It's, again, pretty cool. ClickHouse is used all over the world. And as far as I've heard, it have a pretty nice architecture in terms of code. Unfortunately, I'm not so expert in C++, so I can't prove or disprove it. And like, thank you for your intentions. There also will be some useful links. And now if you have any question, I will be happy to answer them.
Thank you. It was a great presentation. Yeah, let's look in the chat. So there is a question. There are several questions from Muhtadi Bakali. I hope that I pronounced your name correctly. So first of all, are you using tools like Apache Kafka for streaming and processing data?
It's a good question. In Yandex Metrica, we had our own C++ engine for streaming and processing data. Now in my company, we're not using ClickHouse or widely, unfortunately. I like your comment about not slow down as a way of translation.
Yeah, thank you. Yeah, now let's go to the next one. So the question, I think it's more about internal structure of ClickHouse. So why they don't use WebSockets?
Unfortunately, I can answer this question. Like, since I'm not a software developer, I'm not aware about all the architectural decisions inside the ClickHouse engine. But like, if you're interested, I hope one day they will come with meetup to London. I've recently seen that they are now looking for a PR person based in London. So I hope there will be more ClickHouse meetups later on in UK.
Cool. It's a good choice to, it's like a good reason to ask them, maybe to give a talk in Women Who Cut London to answer their questions. Yeah, I think it's more about like architecture of ClickHouse, like WebSockets or sockets or what else there could be. And please talk more about use cases. And thank you so much for giving it. So is there anyone who would like to ask the question? You can also unmute yourself and ask by yourself. Maybe you would like to try it in your company and you hesitated. So there is a chance to ask anything before trying to pitch it to your line manager, for example, or CTO.
Yeah, and like, if you have any questions or now in the future, there is a link to community chat in Telegram, which is like a messenger, and the community answers pretty quickly. I, from time to time, still use it, like to get some answers for my question.
Okay.
Thank you for sharing. I have a question.
Please go.
That ClickHouse does not store text or long text-based columns. If a user is visiting a website and maybe clicking on certain links, does it not have the capabilities to store data like URLs that the user is hitting?
It has capability to store. It's definitely like URLs. It's not so long text. It's more about that storing, for example, the long JSONs and then parsing it in ClickHouse. It won't be so efficient comparing to pre-processing data, parsing your JSON, and like pre-calculating exact like needed columns for you, parse from this JSON, and then use this data. It's more about that, like, you can store in ClickHouse long text, but like it won't work so efficiently comparing to pre-processed data. I remember that I used to parse JSON with ClickHouse, and then like Alexey Milovidov, which is CTO, came to me and said it's disgusting code. Please pre-process data and just like not use ClickHouse so inefficiently.
You also mentioned that in case of denormalized data sets, it would be preferable to use your own custom joins before hitting ClickHouse. Could you maybe give a use case for a better example?
Use case of joins or the normalized table?
In which case would you have to custom join before hitting ClickHouse?
It's more, it will work faster if you do pre-joins comparing to joining in ClickHouse. I believe in many cases it's difficult for me to assess now because like maybe there are some improvements for it. Like ClickHouse has quite a lot of, I don't know, like dictionaries functionality that is something similar to key value storage that like can be in memory, and I believe it can be pretty efficient. Like even without preprocessing. For example, like if you have a browser and instead of storing the whole browser name, you're storing just like ID. So instead of Google Chrome, you're storing one, which is like much smaller amount of information. And then like you can have this translation from one to Google Chrome as a dictionary. It's like a special ClickHouse functionality. And then it will be like, since, as I said, there are like, I don't know, like 100 different browsers, it can be placed in memory and there is no need for joins. But for example, if you have a list of sessions and you have a list of users and like you have billions of sessions and millions of users, maybe it will be in some cases more efficient to do pre-joins before. Like working with data, but again, it's more about trade-off, about spending time to preprocess data versus a bit slower requests.
So I'm assuming it stores some metadata tables for that kind of reference.
Sorry, could you please repeat?
I'm assuming that it stores some metadata tables for that kind of reference, like using one instead of Google Chrome.
Yeah, it's about like metadata tables. Like for metadata tables, definitely in many cases, it's not worth pre-joining, but like it's metadata tables, they are very small, so they can be stored in memory. Anastasia also mentioning as of join. Yeah, as far as I remember, it's something about fuzzy joins, as of joins. I don't remember using it, but like I've heard about them on one of meetups. If you would like to give more information on it, like feel free to unmute and share with us.
Yeah, to be honest, I'm also like not a very experienced user of ClickHouse yet, but I did use as of join in order to do a join when indeed like it finds the first the first closest match, and this way you could, for example, if you need to do two inequality constraints, but then you're interested in the latest value, so this way you could kind of eliminate the common table expression or window function. So yeah, maybe I'm explaining it not in the best way, but if you Google as of join, I think you can find it really helpful for some of the use cases.
Yeah, it's pretty powerful tool. I remember they introduced it like 5 years ago, but like I've never used it for my use cases. Yeah, and as far as I remember, ClickHouse pretty recently, like 2 years ago, they introduced window functions, but before that, there were only array functions. But actually, it was possible to write almost anything using array functions. But it was, I think it was a limitation for ClickHouse because people had to learn ClickHouse dialect to use it efficiently.
Cool. Do we have any other questions right now? Is this your last choice? Yeah, and I shared the links to join Women's Hookup London. Please join us if you haven't joined us yet. And thank you so much for joining us in this evening. And yeah, have a good evening, everyone.
And have a good long weekend.